If you're looking to up the ante from 1080p and want a high refresh rate gaming monitor, then you might want to consider something like the Philips Evnia 27M2N3501PA, which sports a flat 27-inch matte-coated IPS panel, has a resolution of 1440p and a refresh rate that goes up to 260Hz. They also have support for HDR and adaptive sync technologies. Now, at the time of filming and in the UK, it can be found for just £210. And in this video, which has been sponsored by the manufacturer, I'll be covering everything you need to know about it so you can make your own informed purchasing decision. Now, before jumping in, I would just like to give you a disclaimer. If you do want to achieve the maximum refresh rate and resolution, you'll have to be connected over the singular DisplayPort 1.4 input, because should you opt for the two HDMI 2.0 ports, which are found on the monitor, you'll be capped at 1440p at 144Hz. So therefore, some food for thought. Now, in terms of my own subjective testing when it came to input lag, I was actually left pretty impressed. This was with the low input lag mode enabled via the monitor's OSD. No idea why you'd ever want to disable it. Indeed, while playing a hardcore competitive game such as Counter-Strike 2, I had no issues when it came to registering my mouse input and seeing it on the screen. And indeed, this will certainly be appreciated for both hardcore and casual gamers. It is also worth highlighting over here that the low input lag mode does become grayed out when you enable adaptive sync technologies, in other words AMD FreeSync or NVIDIA G-Sync. Subjectively, yet again, I found the input lag was perfectly good, although just not as responsive as when the adaptive sync technologies were completely disabled. Now, another important factor when it comes to looking at this monitor is the overall response time. And here you have got a few different overdrive modes you can select via the monitor's OSD. You've got off, fast, faster, and fastest. As you go up the scale, in other words up to the fastest mode preset, you will get the fastest response time of the monitor, all while getting a slightly worse visual experience due to overshoot, in other words the purple trailing that occurs behind an object. Now, for me to demonstrate and give you some numbers, I'm using the OSRTT tool. And running it at 260Hz and on terms of its faster mode preset, therefore ignoring the off and fast mode presets, you can see that the average initial time, which translates to the average G to G, which most manufacturers claim, sits at 4.06 milliseconds. However, you will notice that the percent in window is at just 60%. In other words, it's not truly hitting that 260Hz refresh rate. Thankfully, it does improve to 80% if you were to go on its fastest mode overdrive. And here, the average initial time actually drops down to a stonkingly low 2.87 milliseconds. The caveat, however, is that the monitor does suffer from quite a lot of RGB overshoot, as you'll be able to notice towards the middle of your screen, therefore making it somewhat unusable on its fastest mode presets. Now, what I actually found to be the sweet spot is actually running this monitor at 240Hz, so therefore disabling the overclock that you could enable via the monitor's OSD. And in terms of at 240Hz and at its faster mode preset, you can see there is absolutely no RGB overshoot. Here, the percent in window is far more respectable at near 77%, and the average initial time is still pretty impressive at 3.57 milliseconds. Now, yet again, if I were to go on the fastest mode overdrive at the 240Hz refresh rate, you can see that there is a lot more error on your screen towards the RGB overshoot, all while getting a better percent in window of 83% and an even lower average initial time of 2.64 milliseconds. Now, to give you a visual indication of what you will be able to see with your own eyes, you can see the UFO ghosting test. Here, at 260Hz and 240Hz, the faster mode preset really does do the best job, both in terms of the darker and lighter shades. While in terms of the fastest mode preset, you can see, namely towards the lighter shades, there is a lot more inverse ghosting. And while it might not be as apparent via the UFO ghosting test, I can safely say that while playing a game such as Counter-Strike 2, or indeed a bit more of a visually intensive game such as Destiny 2, I did find that the monitor did suffer from quite a bit of inverse ghosting, making it somewhat unusable, at least in my case. Now, you will also be able to note that via the UFO ghosting test, there is an MBR setting. And yes, that stands for motion blur reduction, effectively giving you a much more clear image, while sacrificing the overall brightness of the monitor. You've got 20 different level increments to choose from with the MBR levels that can be selected via the monitor's OSD, and here it means that you can effectively get locked brightness and therefore better clarity. And yes, it does actually have a positive impact. And it's also good to see that you can adjust the overdrive modes even while on the MBR setting. Here, just for demonstrations, I use the fastest mode overdrive, but again, the one I would suggest is the faster mode preset. Speaking of which, MBR can be used simultaneously with adaptive sync technologies. Yes, indeed, you can use MBR with AMD FreeSync or Evnia G-Sync, which is actually quite a novelty. And in this respect, there is a setting via the monitor's OSD, which you'll simply have to enable, and it's called Smart MBR Sync. Now, the only downside to this is that you haven't got brightness controls, and furthermore, unlike the regular MBR levels outside of the adaptive sync technologies, you do not have the 20 level increments. It's just simply an on and off switch. However, I did find the brightness to be perfectly usable both in a dark scenario and also a bright sunlit room. Now, this does actually bring me on to adaptive sync technologies, and here you have got a VRR range from 48 up to 260 Hz. Now, in my case, I was able to run Evnia G-Sync simultaneously at 1440p at up to 260 Hz with HDR enabled. Indeed, I didn't encounter any sort of black screen issues or flickering on the NVIDIA Pendulum demo, and better still in a game such as Destiny 2. On that note, it does bring me on to HDR, and it's nothing really to overly shout about due to the overall limitations of the monitor. With that said, the overall HDR image did actually look pretty good. In other words, it looks relatively color accurate. So therefore, if you do have an HDR enabled device, such as let's say a 4K Blu-ray player, a console, or indeed if you're on PC and running an HDR enabled game or movie, then it's something that you might want to utilize. It's good to see that through the monitor settings, you've got a few different HDR modes to choose from, and you've also got full brightness controls, which is always a nice touch. Of course, if you do not want HDR, you can disable it and run an SDR image instead, therefore giving you even more control of the image that you're seeing. Now, this does actually perfectly bring me onto console gaming, and via its HDMI port, you should be able to achieve 1440p at 120 Hz, or of course 60 Hz. Due to it not having full bandwidth HDMI 2.1 ports, it means you will not get VRR support. In other words, you won't have the access to likes of adaptive sync technologies, or more specifically AMD FreeSync. Now, nonetheless, while connected over to my computer, running some objective tests, I was able to notice an average initial time of 3.13 milliseconds at 120 Hz while running the faster mode overdrive, which is the one I would suggest. The percent in window sits at a perfect 100%. Here, the same could be said at 60 Hz, with the average initial time sitting at 3.15 milliseconds. And yet again, the percent in window sits at 100%. Now, while there's quite a bit of RGB overshoot and error that you might have been able to see on your screen, in practice I did find it to be perfectly usable. Although certain individuals might find it a little bit more severe, namely if you were to enable MBR, which is only present at 120 Hz. And indeed, this will clear up the image and give you much better motion clarity, which can be handy for those more competitive gamers who are using it on consoles. So with the gaming section out of the way, let's get on to image quality. And here you have got a flat, matte-coated IPS panel with a resolution of 1440p and a refresh rate that goes up to 260 Hz. Through the monitor's OSD, you have got a dedicated sRGB mode, and it's good to see that you've got full brightness controls. In said mode, and using my calibrators, I noticed a gamut coverage of 92.4% and a gamut volume of 94%. Below you can see how it compares to the standard. The average delta E sits at 1.24 and a maximum of 3.59. In other words, this can be used for serious image editing work or video grading. The tested contrast ratio is pretty impressive for an IPS panel at 1311:1, with the measured white point in comparison to 6504 Kelvin target at 5946 Kelvin at 100%. And below you can see how it compares to the Gamma 2.2 standards. Now, should you want the image to pop a little bit more, I would suggest going out of the sRGB mode, in other words disabling it, and therefore getting a wider color gamut. This will effectively be useful for those people who are watching movies or gaming, but of course if you're going to be image editing, then make sure you do run that sRGB mode. Now, past the color test is bringing me onto brightness, and here surprisingly in HDR I clocked in a lower peak luminance of 412 nits, which is down from 423 nits in SDR. I used the monitor in a bright sunlit room and had no problems at roughly 70 to 80% brightness, but of course your mileage may vary. In terms of its minimum brightness, it drops down to just 74 nits. It would have been great to see an even further range. If you do want to get it even dimmer, you might want to enable MBR, and here at its maximum level 20, it gets all the way down to 61 nits. Therefore meaning that it can be used in certain scenarios in, for example, a pitch black environment. Past the overall peak luminance, we should also talk about brightness uniformity, and here you'll be able to see how my Tesla panel performed across the board. While I do appreciate it's somewhat panel lottery. The same could be said about the overall backlight bleed, where I noticed a little bit of bleed coming towards the bottom left hand side. Somewhat of a norm on IPS panels, but of course your like might vary from mine depending on the panel that you actually get. Now moving on from these tests, let's talk about its overall build quality. And here, this 27-inch monitor won't take up too much space on your desk, thanks to the fact it's got a 3-side borderless design. In terms of the bottom bezel, it's in white, and it also has a little LED, which can be adjusted in terms of brightness or fully disabled, which can be handy in certain scenarios. As for its stand, it's actually pretty sturdy. It's actually made in part of recycled material and provides you height, tilt, swivel and pivot adjustments. In fact, it can be rotated in both ways, which is always a nice touch. Of course, if you do not like the built-in stand and want to replace it, you can have a VESA mounted stand instead, although you will need an adapter. This will therefore allow you to place it on a monitor arm or a multi-monitor setup. Now at the back of the monitor, you might have noticed there's a small little joystick button, and this is to access the monitor's OSD. Here you will find a whole bunch of different options which are comprehensively laid out. And while the navigation will take you a little while to get used to, once you do, it will actually become second nature. As an extension to this, you have also got the Evnia Precision Center software, which does exactly what you might expect it to do, in other words, adjusting settings on the fly. And in case you're wondering, you don't even need it to be connected over USB in order to access these settings, which is always very appreciated. Now to conclude, I would just like to point out that while running this monitor at 240Hz, indeed over here by selecting 240Hz when it was in overclock mode or indeed with it disabled, I did notice a very slight buzzing sound, which was actually quite hard to pick up via my microphones. Nonetheless, it's just something that I should mention in this video and that you should be aware about. Oddly, it was not present at 260Hz, nor was it present at the lower refresh rate ranges such as 120Hz or 60Hz. Now it does bring me on to connectivity, and here you've got two HDMI 2.0 ports and a singular DisplayPort 1.4 input. As highlighted before, the latter is what is suggested. Then you can also route audio via these inputs, therefore allowing you to output it via the 3.5mm jack, allowing you to plug in some headphones directly into the monitor. Alternatively, you can output audio via the two 2-watt speakers. They'll suffice for basic music listening or gaming, but of course, if you want superior audio fidelity, I'll suggest looking at some other solutions. So there we have it. Hopefully you've enjoyed my detailed overview of this Philips Evnia monitor. I'll be curious to know what you make of it down in the comment section below and how you feel it compares to some of its alternatives. If you have enjoyed this video, definitely do consider dropping a like, subscribing and hitting that bell notification, all of which would be greatly appreciated. As such, I've been Totally Dubbed and I'll hopefully see you in the next one. Take care of yourselves and goodbye.